Mount St. Helens is no secret to those who like to climb and trek on its broad, snowy slopes. Especially on the mountain's south side, it's easy to forget what this mountain is capable of, unless you make the trip to the rim for a reminder.
Oh, wow.
This is as close as most people get to Mount St. Helens' dangerous side, an unfriendly, forbidding crater that's off limits to everybody. Well, just about everybody. After signing away our life in liability forms, we were allowed to join the few scientists who do have permission to enter the crater. But we were warned.
You're going in an active volcano. There could be steam explosions. You're dealing with poisonous gas. You're dealing with weather. I mean, you're going into a harsh environment. You're just a visitor, and hopefully you're welcome.
Our helicopter hovered briefly above the 100-foot-high Lewitt Falls before setting down on the north end of the crater.
We're right in the blast. Actually, right at the edge of the crater right here. And if it went off like it did in 1980, we wouldn't be alive to talk about it.
Our only transportation out of here flew off, leaving us alone for the day. And within minutes, we got a taste of what passes for normal in this place.
This is one reason it's closed to the public. Some of these rocks coming down are actually as big as a Volkswagen. And a hard hat wouldn't do you any good.
Charlie Anderson led the way deeper into the crater. He's an independent geologist and volcanologist. He knows the dangers as well as anyone, yet he still gets excited about coming here.
In fact, this is my 140th trip since 1980, and this is sort of a disappointing year because I only made it up here twice. Normally you make it up here 10 or 12 times a year.
The other researchers are here to help document the changes taking place in this exotic, otherworldly landscape. Travel here is extremely difficult. There are no trails in the crater, and the going is slow. Up ahead is the volcanic dome, 1,000 feet high, which has been growing in violent and unpredictable fits and starts ever since the 1980 eruption.
The last dome building event was actually in October of 1986. We had steam eruptions occur without any warning between 1989 to 1991, and I happened to be in the crater when one of those went, and all I did is go behind a rock and just prayed, and the thing shot up ash and stuff about 17,000 feet above the dome. And we were wondering if we ever walk out of that one, you know.
Things are quieter today. Everyone is cautiously wary, yet eager to find out what lies ahead.
It's an adventure. I can't pass it up being a geologist. I mean, I have a volcano in my backyard, an active volcano.
Chris Behrens has been with Charlie on over 40 research trips to the crater.
There's about a cross-section of approximately a 3,000-year history. So just to read the historical part of past eruptions and present eruptions, to me as a geologist, is extremely exciting.
The question on every geologist's mind is, when will this mountain erupt again? Predicting that is the trickiest part of volcano science. But there are other changes taking place here that are worth understanding and possibly worth worrying about. One of the newest dangers is a glacier that straddles the dome that's much bigger than it first appears.
These lines over here are crevasses. Crevasses on a glacier show glacial movement, and it's moving down the mountain actually. From September 2002 to July 2003, the glacier advanced down the mountain 60 feet, which is incredible. In July 2003, there was approximately 80 feet more snow than there was last year at that time.
Charlie was among the first to document the glacier's formation. and his research indicates that it's growing unusually fast.
I don't think anybody in the world has seen a glacier grow from almost the very first snowflake. This is the fastest new glacier growing in the continental United States. While most glaciers are starting to recede up mountains because of global warming, this one keeps advancing. One of the main reasons why this glacier is advancing and accumulating is on the north side of the mountain, which has little sunlight. So the shadow keeps the snow from melting.
A steady stream of dirt and rock also ends up scattered on the ice. This layer of debris forms an insulating blanket that keeps the ice from melting and allows the glacier to build larger and larger every day. Glaciers, of course, aren't uncommon in the Cascades, but the rapid pace of this glacier's growth sets it apart from others in the Northwest. Just 50 miles away is Mount Rainier, a more typical Cascade peak with several dozen named glaciers sprawling down the mountain's flanks. Rainier's glaciers are well known, expansive, and visible from just about anywhere. But Rainier is a relatively inactive volcano, and its glaciers are shrinking. In contrast, the unnamed glacier on St. Helens is growing fast, and it's sitting on top of a restless and earthquake-prone volcanic crater.
One of the dangers would be if the volcano becomes active again, there's a pretty good source within the crater itself of a lahar, a mud flow emanating from the crater if there's a significant eruption.
It's happened before. During the 1980 eruption, the mountaintop glaciers dissolved, joining rock and other volcanic debris to form a massive lahar that swept down the Toutle River Valley. This is not a scene residents want to see repeated. At the USGS National Volcanic Laboratory in Vancouver, Washington, seismographs act as an early warning system, gathering real-time earthquake and tremor information from sensors placed on the mountain.
We're always monitoring Mount St. Helens because it is the volcano that's erupted the most frequently in the Cascades.
Hydrologist Steve Schilling says there is reason to take notice of what's happening in the crater.
Because it erupted in 1980, did not remove all hazard. So I can show you as comparison here between 1980 and 2000. And so you can see as I flicker that on and off, the dome grows and the increase within the crater, sort of a horseshoe shape around the dome of the snow and ice and rock that's accumulating. And so that's a fairly quick period of time for this glacier to develop. Eventually what this will do is fill up, and in who knows how many years from now, eventually we'll have another mountain like it looked prior to the 1980 eruption. And it will erupt again someday.
Here's a good example of
Studying the glacier helps scientists calculate how much ice, snow, and rock is accumulating.
right here is probably a granite.
And whether something short of an eruption, like a big earthquake, could cause a lahar is one of the things geologists want to find out. But the glacier is now big enough that a lahar, if it happens, will probably cause considerable damage.
This used to be almost flat, or let's say a 10-degree angle slope. If you take all that mass out, going all the way around the dome, that's how much is accumulated since 1986. The lahar hazard would be tremendous because all the glaciers that were obliterated in 1980, half of that mess is back in the crater right now. It would take 5 million dump trucks just to get all that snow mass out.
The Toutle River Valley still bears wounds from a series of lahars in the 1980s. The danger today is aggravated because the mountain's throat has been blasted wide open, and only an aging sediment dam, miles downriver, stands in the way of the next debris flow. This dam is filling up, becoming less and less effective over time. Things have been quiet for many years. The visible damage of past lahars serves as a reminder that the mountain that lies upriver shouldn't be ignored. Back in the crater, Charlie continues to document the glacier's growth. But recent trips have evolved into explorations of a previously unknown, hidden world of ice caves.
There are actually 26 entrances up here, and there's 1.75 miles of cave. The caves are continuing to expand, and sometimes they fall apart in different places as the glacier keeps creeping around.
The caves conceal many hotspots in the crater, and they shift and collapse and reshape constantly. So Charlie keeps his trips to the cave short.
In the caves, it's very dangerous because at certain times of the year, like in 1998, for example, we had 445 earthquakes in the month of August. We're just basically studying it to see how they're formed, like is it geothermal activity, and it is a lot of geothermal activity from the fumaroles that are starting this cave.
The caves are misted by steam, and ground vents spew hot and sometimes poisonous gases. Melting glacial ice joins these hidden fumaroles and ground vents beneath the dome, only to emerge as boiling streams that cascade down the mountain. These thermal features provide clues about what the mountain is up to, how active it is, how hot it is, and what kind of changes are taking place from year to year.
This is a geothermal spring or a hot spring. And here's a good example of the algae that grows in it. The darker brown grows in a higher temperature, and then you get the green, which grows at a lower temperature. The water at source is probably about 170 degrees Fahrenheit.
Scientists will continue to monitor the mountain for increases in temperature, as well as any upticks in tremor activity that could trigger a lahar. Yet despite the abundance of strange geologic activity in the crater, research suggests that the mountain is in fact cooler than it was 20 years ago, and is slowly quieting down.
And it's sort of unique. It's the first time we're really seeing that.
People like Charlie are just beginning to put all this information together. Still, there are reminders everywhere that this is New Earth, and is a place where change, even violent change, is a constant. By late afternoon, a haze had filled the air, caused by a near constant cascade of rockfalls and avalanches. Chris and Charlie agreed it was time to leave.
It's a risk, but it's a calculated risk. And that's part of the research. I mean, you know, if no one went into this type of environment, no one will really know what's going on. It's a needed thing to do.
As we lifted off and looked down upon the crater from a safer distance, we tried to pretend once again that Mount St. Helens is the peaceful place that many have come to think it is.